Hi, my name is Sam Headrick, and I'm a solutions engineer at Checkmarx. Today, I'm here to talk to you regarding SAST results in the IDE. Today, I'm going to use the IntelliJ IDE, but the process is nearly identical in all other IDEs. To start, I need to load a project, branch, and particular scan. So I come over here to the Checkmarx view that is reachable by clicking on the Checkmarx icon in the lower left-hand corner of the toolbar, and I choose a project. In this case, I'll choose the top project, Java Vulnerable Lab 2. After that project loads, I'm able to choose a branch. I'll choose master. And we have one scan for master, which automatically loads here, and I can see the scan date and scan ID. Now in the left-hand portion of the plugin, I can see a tree view of the scanners that were run, and I can expand them to see the results. So for this particular scan, only the SAST scanner was run, so I want to dive into those results. I'll start with high severity results. You can see here that there are a little over half a dozen different categories that the tool has detected as SAST potential attack vectors. Let's start with the SQL injection. I'll come here to the second one and choose email check.java, and we can see that the attack vector loads on the right side and middle portion of this screen. Now let's go to the file in question by clicking on the first node of the attack vector here, and it jumps to the get parameter email, which is the source of the data. Now the way Checkmarx works is we look at every source of data coming into the application, so that could be something like a get parameter in this case, and we look at every place data is consumed. So that could be an execute query in this case, and in fact it is if we look at the attack vector on our right. We trace data from that sink to the source, and we determine potential attack vectors during that flow. So we can see here, I can trace through the attack vector. First, we get an email from the get parameter method. We call the trim method on that particular string. That is assigned to a variable called email. We use that email to construct another string, which in this case is a SQL statement that is ultimately passed to the execute query method. Now I know that this is a vulnerability because the SQL statement is being constructed using string concatenation. In other words, we're simply using the plus operator to add the email string to the end of this SQL statement, which is ultimately executed. This has the potential for an attack vector because the email string is not validated, nor is it sanitized, so it could contain potentially malicious data, either inadvertently introduced by a normal user or intentionally introduced by a bad actor. Now that I've confirmed that this is an actual vulnerability, I may want to come in and learn more about it. We see here we have a description, which basically gives a textual representation of what I've just said verbally. We can also go to learn more, which gives me information about the risk, the cause, some general recommendations, and then if I come back and look at remediation examples, it shows me the anti-pattern that I'm currently using. So in this case, it's very similar to what I've seen above, except it's concatenating a username into a SQL statement and ultimately executing it. And once I understand that, I'm able to create a couple different examples that I can mimic and use that to resolve my issue. So here we see a sanitizer and a prepared statement. Now I'm able to do a couple other things in this view. One is I can change the severity, and the other is I can change the state. So the state currently is to verify. All findings initially come into your view in a state of to verify. And that means our engine has detected it through tracing that data flow as a potential attack vector. You can choose to say that it's not exploitable or a false positive. You can propose it as a false positive, or you can confirm it or mark it urgent as true positive. Now, you may wonder why there's a proposed not exploitable in addition to a not exploitable, proposed false positive in addition to proposed false positive. And that's because the Checkmarx One system has a complex role-based access control system where you may allow some users to only propose something as a false positive, and then other users actually be able to come through, filter on those proposals, and elevate or demote them as it makes sense. So we'll say that this is a confirmed vulnerability because, as I went through earlier, it is something that is vulnerable because we're using that string email that's coming in from the request parameter to construct a SQL statement. Once I've created my changes here, I can click on the update button, and I can also add notes. Now we can see that those findings have changed, and this finding has now been removed rather to the medium branch of the tree. Let's re-expand the high branch and look at another example. In this case, I'll look at a stored cross-site scripting example. And we can stroll through and see what we have. A number of JSPs, a number of Java files as well. I'll click on the first JSP, which is forgot password. You'll notice that the pane on my right updates, and if I click on the attack vector flow, I'm able to go into the code itself and see how this attack vector flows, which is a little bit different than the SQL injection attack vector. So we can see here that we actually have a SQL injection in this case, which would be another finding. But what we're doing is, after we execute that query, even if the SQL injection were remediated, we're enumerating over the results of that query. And you can see here that we take the results of the query, and without sanitizing them or validating them, we print them to output. And the potential for a cross-site scripting is the data we get back from the database could be tainted with, for example, JavaScript code that would then execute when we printed this to the output and cause inadvertent behavior that we did not want. Let's look at one final example. Unsafe reflection. We can see here that when I click on it, the pane updates to the right, and I'm able to go to the top of the attack vector again. We can see here that the JDBC driver is coming in from a get parameter from the outside. So as we discussed with the previous two attack vectors, variables coming in from the outside need to be considered tainted, potentially tainted, and if they're not validated or sanitized. So let's jump to the end of this attack vector, and we can see here that we're instantiating JDBC driver using unsafe reflection in this case. The reflection is unsafe because that JDBC driver is coming from the outside. Again, I can change the severity, I can change the state, I can also add comments. That concludes the demonstration of this particular IDE. And that's how you review SAST results in the IDE. If you like this, we have a lot more videos on how to work with Checkmarx on our YouTube channel. Check out the link in the description for more.